Can someone confirm whether you can hear me or not?
Yes, sir, we can hear.
Yeah, thanks. Thank you very much. First of all, thank you very much for inviting me to have this engaging session with the Green Building Council. So what I'm going to discuss here today is some of the current topic on now the climate change, climate actions, global warming. So it's a common thing now. So most of the people are well aware about that. So I thought of discussing, as with the introduction, she mentioned that the complexity of the carbon market. So there are different arguments on this carbon market. We'll try to understand what is this carbon market, and I'm happy to share some of my experience, and also I try my best to answer your questions if you have anything. But otherwise, even later on, I can give you some clarification on if you have some of the concerns related to this topic. So just to very quickly to understand, now we all are well aware with this climate issue, the global warming and the other issues. So global community, the scientists, and they have given the warning to the humanity. Now, the Grd.I is given with the issues that we have experienced, extreme meteorological event and things, and also in 2021, Antonio Guterres, he has actually, after the IPCC report on the annual the climate impact assessment report. So with that, the warn in 2021, almost 3 years back, it's kind of a challenging, and it's kind of a warning for the humanity. Now, what we are experiencing, the issues actually what we have created, that is actually confirmed. So now we are in the process of finding some solution on that. Now, when you talk about the climate and the global climate, I'm not going to go through this climate science. However, it's now proven thing. Earth is warming, and it's a law. With the history of record of information, now the 2023 recorded as the highest the warming year. So these are now become the couple of decades back. There were some argument on this climate change or global warming is really happening or not. But now it's confirmed, and people are now working to overcome some of the consequences that we are experiencing at the moment, and also the probable issues that we are going to experience in future, probably not in our life, but in the coming generation, they are going to have. That's the warning, the given, and now it's very well understood. Now, when you look at this, the title, the discussion, to continue with the discussion. So very simple background on the what is this climate change, and we know that greenhouse gases, and hope that in this audience are well aware about this type of thing, as with the previous discussion happened in this the same forum as well. So we know that the greenhouse gas is a gas is required to have the life on Earth. But now actually we have broken the balance of these greenhouse gases. So without having greenhouse gases, we probably the life we cannot find life on Earth. So because all the radiation coming from sun during the day, and will not probably there's no ability to trap, and during the night time, so there are kind of the no retention of heat. So if assuming if we don't have a greenhouse gases, but however, with the human activities, we have uh, uh, due to our the uh, uh, especially after the industrial revolution. With that industrial revolution, we have extracted fossil fuel and we have started burning it in the machines to get energy for our work. And with that, we have really started releasing more and more greenhouse gases to the atmosphere. With that, as we all know, the greenhouse gases, they can trap heat energy of solar in simple terms and retain in the atmosphere that will enhance that will create the global warming. And then with the global warming, we know that the all uh, wind pattern and things can change, and with that, so we experience different uh, weather patterns, extreme weather events. Now, and if we are thinking of addressing this the climate issues or impact, uh, what we can do is we need to balance the release of greenhouse gases, which is the main thing that contributing to climate, the global warming. So this is where we can think of, and we know that there are different types of greenhouse gases, and very common greenhouse gases, commonly know the some carbon dioxide, methane, nitrous oxide. These are actually naturally exist greenhouse gases. In addition to that, we will have created uh, uh, very many greenhouse gases for our purposes. Even if you see few greenhouse gases here, but if you can search in the web, and also if you go for the IPCC assessment report, you can see more than 300 of greenhouse gases exist. So these most of the greenhouses gases are used for industrial activities. However, when we are thinking of addressing this climate issue, what we have to do is we have to control of releasing of these greenhouse gases. And we know that the releases of these greenhouse gases due to our activities. Even now, when we are using electricity here, and we know that somewhere in Sri Lanka, the national grid, we are generating electricity by burning fossil fuel, some the solid or liquid fossil fuel, and that this generation of electricity will release carbon dioxide, nitrous oxide, and methane, and those type of gases that will create impact elsewhere, even though we are using electricity here. So this is very general background, and also we have uh, uh, realized that we need to maintain the temperature, the increase variation below 1.5. And if we go beyond that, there will be huge issues for the humanity, not only for the humanity, for the entire the system, system. So, however, with that, all the nations are realized that we have to maintain the release of greenhouse gases. So, if you look at this, the graph, it's one of the report published by the United Nations. We see we have to now human-induced warming. Now we are talking about human-induced activity. There are natural processes also. They are uh, creating the global warming. But however, now the issue is that we have to consider the activities that we have created and the human-induced warming. Now we have to we have to find some of the solution to reduce. Now to maintain, according to some of the estimations, now if we continue business as usual scenario with the current activities in the all the economies in the world, so this will continue, and by 2040, will reach to the expected current the warming rate that we need to maintain. So, however, to maintain the temperature well below 2 Celsius, so we have to take some actions. However, on this, when you look at the global interventions or initiatives or uh, uh, policy drives to address this, started long way back. However, still we have to, we are talking this and we are taking some of the decision. In 1992, actually, the summit in Rio, UNFCCC is open for signature along with the Rio Convention. Even with the biodiversity, there are certain concerns that address. And then the 1995 COP1, and then the 1997 Kyoto Protocol. One of the important milestone in this climate action. So the Kyoto Protocol, they have taken some of the target and setting targets to reduce the global emission. However, in coming years, all the economies did not achieve that. So, however, in 2001, Marrakesh Accord, implementing a Kyoto Protocol, and then the COP8 extended up to 2020. Now, actually, already 4 years gone in 2020, and then 2007 at COP13, they have come up with the roadmap to address some of the actions, and likewise it continued. Now, even 2021 at COP26 came up with the Paris Agreement, addressing the stringent intervention from all the nations to address this issue. And in Paris Agreement, one of the key decisions taken, all the countries agreed and realized that we have to maintain for the existence of our especially the existence of the humanity. So we have to maintain the global temperature below 2 Celsius. So in that, there are important actions being taken in that Paris Agreement, especially. So this is where the discussion that we can start what we're going to discuss today. Article 6 of Paris Agreement, there are few subcomponents in Article 1 and especially Article 2 and Article 4. They have discussed on how international cooperation and how these countries commit on reducing, taking the commit on mitigating the emissions in country level. So with that, countries develop nationally determined contributions. I'm not going to discuss much on these. Most of the countries actually they have came up with their commitment targets. They have set target covering industries and all the other sectors. So and also Article 6.4 highlighted that the framework for collective implementation of these mitigation measures between different parties. We know that this climate change, the climate issue is a global one. It's not localizing the impact. Even we experience the impact in the locally, but the climate, the cause for the climate change is a global scenario. So, and we know that in simple terms, releasing of greenhouse gases to the atmosphere, there's no boundary. Therefore, if we are thinking of addressing this issue collectively, we have to have a approach to mitigate this release of greenhouse gases collectively. So the Article 6 addressing some of the main component, and then the COP28 they have actually further discussed on the mitigation actions, and then the very recently concluded the COP29 the discussion. They say that they have actually ended with the 300 billions of commitment from different countries to address this climate issue. So we know that to address the climate issue is multifold. Now we have to find some of the solution to mitigate greenhouse gas release to the atmosphere, and also we have to have support mechanism to the finance some of the issues already experiencing by the humanity in different countries. So the parties engage with this COP29, and they actually committed to put $300 billion. However, they have highlighted that this is kind of insurance for humanity. So it's like they have to commit, and they have to, as they committed to this, they have to really engage with providing premium or whatever thing to get the real cover of this the environment impact. So that those are some of the policy, the global level policy initiatives, and with that, generally there are a lot of discussion on moving towards low carbon economy. We know that the fossil fuel burn is a critical factor for the climate change. We need energy to run economies. We need different policies and different types of initiatives, and it's very well established, and different economies, different countries in different region, they are addressing these in a different way. However, when we think of addressing these climate issues, emission reduction is a key. Now we all have realized that we have to maintain or we have to minimize further release of greenhouse gases to the atmosphere. Now already we cannot say that we have surpassed the level that we have to maintain the greenhouse gas at the moment. However, still we know that the Earth is having the assimilative capacities. So still we don't see any collapse. But however, if we continue releasing greenhouse gases to the atmosphere, there will be a collapse on this system. So therefore, we have to start reducing the emission. And now globally, people have now setting targets to reach the emission, net zero to the atmosphere. So, however, we will discuss some of these terminologies where we can think of applying in our the context, especially in organization level and other contexts. So we have to set some of the targets. Now, if we set some of the target, we have to take some of the action to reduce that. So when you talk about this climate, the reduction of greenhouse emissions, if we are thinking of reducing greenhouse gas, for example, this is actually I have taken very stringent approach in this schematic diagram. Even in a country or an organization, they can identify the emissions releases in a particular year, and then we have to identify some of the actions to perform to reduce these emission. So ultimately, we can reach to the zero. However, technically, to uh, uh, make our emission zero, it's not possible. However, there should be different approach. So we will discuss some of the approaches later. And when we talk about the emission reduction, there can be different approaches. However, in generally, if we are planning to emission reduction in any kind of any organization, the reduction has to be a project. Now, even in an organization, even in a country, as if we are targeting to reduce emission, so we have to identify what is the baseline emission. So then we have to have a project to reduce the emission. So in that case, we can reduce the emission. Now, if you look at some of the approaches that we can take, if we take a very simple approach to reduce or the prevent releasing of greenhouse gases to the atmosphere. So it's very simple mechanism. It's a nature-given approach. If we have more trees, if we can plant more and more trees, so the trees can absorb carbon dioxide. But we have to understand that trees cannot absorb other greenhouse gases, as I mentioned previously. So there are a lot of greenhouse gases, but the trees can absorb only carbon dioxide. That's why there are certain misconceptions on when we are talking of these climate actions. Planting trees will not be only the solution for something. So it's kind of a support to a certain level to address some of the things. In this particular case, this is kind of we can consider it as a nature given solution to address to a certain extent of climate change impact. So they suck out carbon dioxide from the atmosphere. So that is kind of one approach. So naturally, we know that in forest, and this is in the land, yes, we have forest. In addition to that, in the oceans, we have algae. These algae also absorb carbon dioxide and fix in their bodies, and that will help us to reduce some amount of greenhouse gases, but only carbon dioxide. So when you think of doing something to support atmosphere to remove greenhouse gases, we can come up with a different type of project like reforestation or afforestation. We can plant trees, and if you plant trees with the growth of plant, they absorb carbon dioxide through their photosynthesis and they fix in the bodies. So that will, at least for a time period, they can remove atmospheric greenhouse gases, or especially in this case, carbon dioxide from the atmosphere. Then that will at least help to reduce the global warming. Now, on the other side, if we can think of emission reduction, right? So assuming that if we are going to have a renewable energy project, considering that currently we are having electricity generation using fossil fuel. We burning fossil fuel release greenhouse gases. But if we can replace some of the energy generation by introducing renewable energies like wind, solar, or mini hydro, generation of electricity with this type of renewable projects, will not emit greenhouse gas compared with the electricity generation by fossil fuel. We cannot say that these renewable energy projects will not release any amount of greenhouse gas, but there are emissions of greenhouse gas due to different activities. However, we can replace or some of the at the end, if we can add this type of renewable energy to the national grid, so can obviously help to reduce release of greenhouse gas. So because total generation will compensate with renewable energies. So these also another approach. Now, when we think of climate impact, if you are thinking of reducing climate impact, one we can do is do something to remove greenhouse gas from the atmosphere. That's one approach or one type of projects. And on the other hand, we can do something to reduce greenhouse gases to the atmosphere compared with the existing the scenarios. So if we can have different approach to minimize the control the release of greenhouse gas to the atmosphere of existing project, that is one approach. And also if we can do something to absorb greenhouse gases from the atmosphere, it's another approach. So when we going ahead now, if really finding solutions, a technical solution. So the couple of years back, actually, these are only the concepts: carbon capture and sequestration, for the CCS. The concept was to absorb greenhouse gases, especially the carbon dioxide from the atmosphere, and pump in the deep sea or Earth. So the the ocean carbon sequestration or Earth carbon sequestration. If you pump capture carbon dioxide from the atmosphere beyond 3 kilometers, actually that the carbon dioxide will react with the salt water and form something which is not released back to the atmosphere, and that will help to reduce some amount of atmospheric greenhouse gases. Those are actually concept in a couple of decades, but now if you probably heard this, Okra, the first large-scale plant, actually located in Iceland. So they have established plant to absorb atmospheric carbon dioxide and fix in the ground. So they have the present day, the capacity is around 4,000 tons per year. So they can they capture from the atmosphere directly through a process, and then they store in the ground. So, and they claim that these stored carbon dioxide will retain or the remain in the soil at least for 10 years, 10,000 years. So this is possible, and it's proven now. It's actually established in 2021. But compared with the natural process, planting trees, and this again man-made high technical approach, so it's a huge cost. But now these type of approaches are also now people are thinking. So, however, we have to think that how feasible these type of thing to address. And if you are thinking, okay, wait and see, technology will uh, develop, and that will do the needful to address these issues. I think that will not be the way that we have to think. So, however, the people are now uh, thinking this type of different approaches, like the what we call the system engineering approaches, and also now people are thinking of setting up reflectors at the upper atmosphere to reflect solar. So these also can be done to address this climate change. But however, uh, than that, we have to think of different approach. Still, we are in the safe side. If we still, there's a possibility to maintain the atmospheric greenhouse gas concentration below the if we would say the catastrophic level of greenhouse gas uh, at the atmosphere. So with that, now people are thinking of uh, addressing or achieving uh, net zero. Now people are coming up with different approach, and now it's become reality. If you look at this context, I'll go through some of the examples later. Uh, and also now people are talking about the carbon neutrality. Uh, most of you probably have heard about carbon neutrality, carbon offsetting, carbon incense. There are different terminologies. Now, uh, there are certain approaches. Now, if you look at this uh, simple diagram, now in an organization, we see some emissions. Now, we can reduce certain emissions by doing different project to reduce the uh, emission. For example, if we take an organization or the company, if they uh, use uh, electricity with the conventional machineries, if we can come up with more efficient machineries or lightings, so the use of electricity the will reduce. That will reduce the release of indirect greenhouse gases. That will actually support nationally to reduce the greenhouse gases to the atmosphere. However, we cannot expect to make it the 100% reduce. So we have to, technically, it's not possible to reduce to zero level. So, however, if some organization is committed in this climate action, so they can, what they can do is they can support some other project which will doing some kind of activity to absorb carbon dioxide from atmosphere, or a project uh, they support to minimize releasing of greenhouse gas for the atmosphere. So with a financial agreement, so the transaction, so the organization can achieve carbon neutrality. So this is a very simple approach on that. However, in the technical explanation on this net zero or carbon neutrality, uh, carbon dioxide are achieved when anthropogenic carbon dioxide emissions are balanced globally by anthropogenic carbon dioxide removal over a specified period. So net zero carbon dioxide emission are also referred as a carbon neutrality. Now here, even though it's, if we refer to carbon dioxide, so it can be the collective impact of total greenhouse gas, which is carbon dioxide equivalent. Now, uh, it's in here, it's highlighted that anthropogenic emissions. Now, we can offset human-induced emissions by human-induced activities. Now, if we are thinking of claiming carbon neutrality, assessing the amount of greenhouse gas absorbed by naturally exist forest, which is not actually recognized in this net zero concept. So if you take some of the example in Sri Lanka and the global context, now this is one example randomly selected as it is publicly available. In Jawaharlal University, they actually estimated their greenhouse gas emission per year period, and also they have maintaining a forest in the different area, 400 hectares of forest. And what they have done was they have started tree planting project, and they have estimated the amount of greenhouse gases, especially the carbon dioxide, can be absorbed by this tree planting project in 20 years time frame, and that also verified through a third-party verification process, and also the emission also accounted following some of the standard, especially if we mention the standard here, the ISO 14040, ISO 14064 part 1, which is for organization level emission estimation standard, and they have verified that. And also the project in that forest area is verified again following another standard for 14064 part 2, and amount absorbed by the trees that planted by the university, and the estimated amount of carbon dioxide absorbed by the tree, and compensated with this third-party verification approach. So with that, actually, they have claimed the carbon neutral university or something. So likewise, there are different approaches in that. In here also, you can see that the Asia's first carbon neutral cage-free egg. This is also what they have done was they have minimized their emission first, and also they have, in this particular case, they have purchased carbon credit or carbon offset to neutralize. So likewise, there are different approaches, and in here also there's another example, the carbon neutral chicken. So I just need to give you a different example. Now even the building carbon neutrality, and there are a lot of examples are there, and this is also a Sri Lankan one. It's one apparel product from MAS. They wanted to make it carbon neutral. What they have done was they have started another organization started a project, tree planting project with the community, and that project is actually verified. Then this verified carbon credit used to offset that. Actually, this is the very first Sri Lankan uh, uh, verified and registered carbon credit development project. I will discuss some little on the carbon registries later on. So likewise, organization level, the carbon neutrality approaches are there, and also even the product level. This one product from one apparel manufacturing facility. They have calculated the carbon footprint of the particular product, and by purchasing carbon credit, make it carbon neutral. And also now we see some of the trends in the organization, not just calculating carbon dioxide. Now these actually very uh, recently come up with the recent standard, pushing organization to do real and absolute reduction. So I'm not going to go through this approach. However, they need to reduce absolute emission over the time. And this is also, again, a voluntary standard. The organization can commit on that. And even Sri Lanka, there are a few organizations, actually, they have committed this international standard, saying that their emission, target emission, current emission is reduced by some percentage in the coming years, and they have committed and they have to demonstrate that they are working on. And also there are certain standards there on the carbon neutrality. So a lot of things are happening supporting this the global climate action, especially focusing on carbon neutrality. Now, if we look at this carbon uh, uh, mechanism, now we see that some organization, they try to reduce carbon emission, and also they come up with some of the claim that they are carbon neutral or carbon free or some kind of thing. For that, it's a kind of a mechanism where it's now uh, uh, well recognized. There were some of the issues in the early stages of this carbon crediting and trading mechanisms. Now, when we look at this carbon trading term, so normally we consider as the carbon. Another term that we use is carbon offset. Now, if you look at the technical definition on this carbon offset, so it's carbon offsets can be a 1 ton or any amount, or whatever the emission reduction, right? Emission reduction, as I mentioned previously, if we can do something to reduce the existing emission, it's one approach. And or if we can remove the greenhouse gases from the atmosphere and fix in the long-term whole. If that result from the action outside the organization boundary, if it is something outside the organization, and if we can use to counterbalance the organization, whatever the residual emissions, to need to do as much as possible reduction, and the residue can be offset by these approaches. Now, if you look at this emission reduction, the technical definition for that is quantified decrease in the greenhouse gas emission, especially related to arising from an activity between 2 point of time. Now, it has to be a project, and with the two timeline. So you have to demonstrate that the reduction, and also the removal also the same. We have to demonstrate that in that particular project, the atmospheric carbon or the greenhouse gases are removed due to human activities. That means the project induced by human. So with that, actually, we can identify the offsets. So that means it has to be a project, and this project should be with that activities, actually the emission reduction or the removal can be calculated. And if you use the term credit and the versus the offsets, there are two terms, GHG credit and the GHG offsets. And in this case, normally offsets are usually represented by the GHG credit. The credit mean it's kind of a tradable. Now we cannot, it's not tangible thing. So now ability of absorbing greenhouse gases by trees, we cannot actually, it's not a tangible thing. So however, we can estimate the amount of greenhouse gas absorbed by planting trees or something. Or if we can estimate the amount of the reduction of greenhouse gas release due to certain project like solar power or whatever. Now, so the transaction is done with some kind of releases of certificate. So those who need to reduce their emission or the claim that our emissions are neutral or something, what they can do is they have to get a certificate from the project done by somebody, some other organization elsewhere, claiming amount that they have reduced. So same concept, but however, the use of terminology is something different in these two contexts. Now, when we look at the global the carbon market, so there are two types: mandatory market and voluntary market. If you see some of the if you the countries, some countries they have actually the carbon taxing and other approaches. In Sri Lanka, we don't have anything regulated so far, but in future there can be regulations on this carbon trading. However, I'll show you some of the example in Sri Lanka at the moment. There's a kind of a scheme it's already developing. When you look at the carbon credit, so this credit actually generated with some of the projects. These projects actually support climate impact. So in this case, we can come up with the two types of carbon, the credit. If it is a regulatory requirement, so we consider it as a certified emission reduction. And if it is a voluntary approach, we consider it as a voluntary emission reduction. So when you look at different types of carbon credit, there are multiple carbon credit projects. So if we look at this carbon credit generation, the ecosystem or the process, we had to have a project developers, like as I mentioned previously, in Kanmelia project, what I have mentioned previously, in that MA's, the carbon neutral bra project. So the carbon offsets are generated in a project. So they have to have a project developer and they have to follow some of the standards to come up with the project to demonstrate the carbon the removal from the atmosphere, or project like if it is a renewable energy project, mini hydro, or some kind of project, you have to demonstrate that the emissions are reduced compared to the baseline scenario. So this is the project development, and for that some people are there to invest this project, and this project has to be verified by third parties, and this verified to do this verification or to implement this project, there should be some kind of internationally or accepted methodologies, so which we call the offset program. And also to there should be somebody to purchase these credits. If there's a demand for this credit, so this transaction can be happen. So there are intermediate purchases of this credit, and then the retail transactions can be done, which is at the end to get that claim. What the organization is normally doing. So the credit buyers are the people who buy this credit from this project. So that transaction will support to running that type of initiatives, which is supported climate impact. Now, when you look at this project standard, these are the voluntary project standard, BCS standard, climate action, global standard, PANGO. These are some of the standard, and there are a lot of methodologies. Currently, it's more than 170 type of carbon credit projects are available. Sectors: forestry, renewable energy, the household, community, the chemical industry, even with the waste disposal. So with this, the projects, how they generate carbon credit is, if it is, for example, if you take waste disposal, if the current practice of waste disposal is emission amount of greenhouse gases. If we can come up with a different project of disposal of waste that will release X minus some amount of greenhouse gases, that can be considered as the greenhouse gas mitigation project. However, so we have to, the project developer should comply to different standards, and there are different criteria that they have to fulfill. Now, if you look at these common standards, there are these actually voluntary available standard in the global market, which is prominent. They have actually developed different methodologies to do some projects. Verified carbon standard, gold standard, American Carbon Registry, and the Climate Change Reserve. So all these projects should go through a project cycle. The project plan should be validated first by third-party validation bodies, and then the project accepted project emission reduction should be verified with the time stipulated by the standard. And if you look at the project offset cycle, project idea, so initially they have to come up with a different project idea, and then they have to develop project, and then they have to go through the validation of this project, and need to develop the project on the ground, and the estimated carbon credit can be registered in registries. And then these by these registries, the buyers can purchase. Actually, this is the most credible and recognized approach. Now, project can register in the independent registry, and with that registry, the people can use this credit to claim their carbon neutrality, or to come up with any kind of a claim. So this is what we call the carbon, the retirement. So if we take some of the registries, this is actually American Carbon Registry. So just to get some idea about what exactly the registry looks like. Now you can see that it's a kind of independently operated transparent mechanism. Now the project can register once they get the verification, so they can register their amount of carbon credit reduction or removal in this registry. In this particular case, if you look at this first one, quantity of carbon credits, that means the ability of carbon removal or the reduction from that project is about 30,000. So that is registered in the registry. Now, somebody can purchase that credit if they are interested on this type of project, and they can go to the registry and they can purchase some credit. That means they pay some money, and this money is going to support that project. So that is the approach of carbon registry. Now, if you look at the carbon market, just to get some idea about the pricing and things, and in this is actually the voluntary market that I'm talking here. So these are not regulated, it's a voluntary market. According to the very recent analysis of the voluntary carbon market, during the previous years in 2023, the total reported transaction value is about 723 million US dollars. So if you look at the trend now, you can see that in 2005, 2003, this voluntary market, global market is increasing. However, we see some kind of a drop between 2022 and 2023, probably due to different reasons. The economies, even just after COVID, there can be some of the issues. So is the amount of carbon credit. Now, when you look at these figures, what we can understand is the transaction from organization to those who are willing to contribute to the climate impact reduction, even though they cannot do what they do is they support other projects by paying money and by getting carbon credit. That actually is kind of the organization, those who are getting carbon credit, actually they probably have a different the advantage on that. And when you look at the size of the carbon market, annual volume, it's in 20 total cumulative volume by 2023, it's about 2.4 billion of carbon dioxide tons of carbon dioxide equivalent being traded between these projects. That means the projects, the organizations or entities supported engaging with this type of project on this much. So, and also if you look at different types of project registration, so you can see agricultural related projects, energy efficiency, and the transportation, even waste disposal, and different types of project. See, and with the time you see that in 2023, there are more projects being registered in registries, or the more carbon credit is registered with the projects in household or community level. For example, if you take one example, there are certain projects on improved cook stoves. So giving some support for the communities. So if somebody, some organization can come up with the improved version of cook stove, those who are using biomass, the total reduction, if they can estimate the total reduction, that can be a carbon credit project. So likewise, there are different types of projects available. And also, this is just to get some idea about the price of a carbon credit. Now, you see, forestry and land use type of credits by 2023, that is the highest. Now, approximately, this is actually the average price. So $9.72. That means that if you purchase 1 ton of carbon credit, the project developer will get $9.72. Actually, however, this $9.2 is not exactly directly transferring to the project developer. There can be intermediate the transaction with the registry owners as well. So now, if you look into these different prices, now you see forestry and land use type of credit having more value. So normally, when you look at the carbon market, we see the nature-based solutions, the project with more nature-based solutions rather than climate impact mitigation. So have more value for the more demand from the credit buyer. So that's why this we see the high price for the forestry and land use type of project. And specifically, if you look at this that category, there are different types of credit. And if you look at this segment, especially the forestry and land use category, afforestation or reforestation type of project is average carbon credit price is around $15.74. So, and also there are certain other methodologies like improved forest management. For example, if you have a plantation with improved forest management with providing fixing of carbon dioxide in this plantation, so that type of projects will get more credit according to these standards. And also we look at this blue carbon is the carbon, the project associated with the coastal and marine ecosystems. However, in this at the moment we see some of the issues with the global carbon trading market. Some people claim that these projects are not reliable. So even though if we take carbon credit, the credibility of real project is operation on the ground is questionable. Therefore, now there are certain discussion on creating a credibility on this carbon credit. So with that, there are certain initiatives like for carbon principles. So some organization, independent organization, they do validate, verify beyond the third-party verification to recognize these carbon credit projects are real. And also going beyond that, now new trends are there, like blockchain and tokenizing of carbon credits. So even PricewaterhouseCoopers, so these are some of the initiatives to uh, create the credibility of this, to uh, uh, see the traceability of this transaction is really happen, because otherwise there are certain issues like double counting. Some in this particular carbon credit market, we see some of the issues like people have uh, uh, question about whether these carbon credits are really support the climate impact. Sometimes can't we retrade these carbon credits? Those are type of issues are there, and there are certain issues also raised recently with this carbon market, some of the project as well. So therefore, people are now coming up with different approach to uh, uh, create the traceability and also the credibility of the carbon credit that the project are developed. Now, so those are mainly on the uh, voluntary carbon market. And if you look at the mandatory market, which is we call it as emission trading schemes. So country level, there are different types of emission schemes available. I'm not going to go through uh, detail. So the idea here is some countries, they have their own uh, mechanisms or the processes on carbon trading, or the in between the targeting mainly on carbon, the reduction of their different sectors. Now, if we quickly go through the kind of a mechanism with this uh, carbon trading, if we take EU emission trading system. Now, this is one of the very first this type of carbon trading uh, emission trading system operated in European Union, covering few countries, and they also after COP29 come up with they have committed actually to uh, reduce carbon to reach carbon neutrality uh, in January 50. So they have started setting some targets to make it carbon neutral in the EU countries. So in that emission trading scheme, really, in that particular case, what they do is in between, they have given some of the allowances for different industries. So industry A, if they have, if you take this example, industry A, the allowance, if they have not actually reached to the accepted allowance of emission. Therefore, they have some kind of a remaining amount. So some organization, they have actually uh, going beyond their allowance. In that case, what they can do is they can exchange their allowance. So this is actually what is happening in this emission trading scheme. For example, the emission allowance in this particular organization is assuming that it's 100 tons. In this organization, actually, they have gone beyond that emission. But in another organization, the allowance is allowance for the to emit emission is 100, but they have actually maintained below that allowance. So therefore, they can trade that allowance to other countries, so other things. So in this case, actually, the those who are committed to reduce will compensate that the financially compensated by other organization. And actually, this in the European Union emission trading scheme, actually they have set some of the targets. Allowance are actually reducing time to time, and by that they are going to make it entire industry sectors, including transportation and things, neutral by 2050. So this type of how those type of approaches are affected to our countries, like the countries like us. In this that particular case, EU companies, they have approach, and non-EU companies, they have uh, actually, to entering into that market, they have to pay border carbon or the border carbon tax. So this type of mechanism also described in that type of emission trading scheme. Now, if somebody is entering into this EU border, carbon border tax has to be paid. Now, in this type of emission trading, these are actually regulatory schemes. Now you see that in the today's market price for one transaction is about 69 euros. So likewise, these type of mechanisms are available in the global context that will support these actually market-based approaches, support to balance out emission uh, uh, or the release of emission to the atmosphere, creating climate change impact. Now, if you look at the Sri Lankan context very quickly, in Sri Lanka also, there's a carbon crediting schemes already developed to a certain level. At the moment, actually, they are working towards enhancing this thing. This is actually under the Ministry of Environment, the Climate Fund. They operate Sri Lanka Carbon Credit Scheme, and they can projects, the national project, if they follow some of the standards, they can verify and they can register the credits in this registry, and those who are interested on purchasing credits, they can purchase. However, these are not, at the moment, it's much not recognized the global market. However, this is also, at the moment, it's a voluntary registry. Now, if you look at the interface of that carbon registry, so you see the different type of project and all the documents are available. That is the main intention of this carbon uh, trading platform under some of the emission trading scheme. So amount can be the carbon credit amount can be actually checked with the registry, and if if somebody is required to purchase some carbon credit from these projects, they can purchase through this type of crediting platform. So that's the main thing I need to highlight here. And also in Sri Lanka, they have the country as a country is developed a carbon net zero target roadmap also developed. And even though we don't have a voluntary, the regulatory framework currently, by 2050, the Sri Lanka country also have target to make it carbon the neutral. So to make it neutral, so we have to have reduction approaches and also nationally determined contribution from different sectors. And also we have to have some kind of mechanism to have emission trading. And supporting this financial mechanism in the central bank came up with the roadmap for sustainable finance. And also Sri Lanka have a green finance taxonomy developed. And in addition to that, to support those internationally available different type of standards, green finance standards are available to verify, to get a credible project registered in the searching for climate finance. So these are some of the standards available. And so this is generally what I need to explain. Sorry, I have taken much time. So, but however, if you have any clarification, I can clarify those questions.
Now is the perfect time to engage with our audience. If you have any questions, please feel free to ask them now.
There's one question in the chat box. How can we measure or estimate the absorption of greenhouse gas, especially carbon dioxide, by trees? Yes, now there are certain equation already developed. If we know the tree diameter and the height, and there are certain allometric models being developed. And if you know this, then we can estimate. Otherwise, it's in this type of thing, it's a somewhat direct. For example, if you know the weight of the tree, this is a fundamental principle of calculating a carbon, what we call the carbon sequestration of a tree. If you know the volume and if you know the density of this tree, then we can convert into what we call the biomass. And the dry weight of biomass, the 50% of the dry weight of the total mass contain carbon. For example, if we can weight a tree now, so this is something different. If you are planting a tree now, trees absorb atmospheric carbon dioxide, and through the photosynthesis, they fix certain amount of carbon in the body. Now, to estimate the amount of carbon dioxide absorbed, so we can follow that type of approaches. So first, we need to estimate the volume of that particular tree. Now we know that the estimation of trees, the volume of trees, there are different shapes. So however, certain species, there are certain developed regression models, allometric regression models. So we can use these models, and by taking some of the ground measurements like diameter or a girth and then the height, and we can develop, we can estimate the total biomass. Now, if we take a weight mass of estimated amount, the estimated weight mass of that, normally the 50% of, if it is, if we convert it into dry mass, the 50% of with the carbon. Now, to have that carbon, according to the stoichiometry of the photosynthesis, so they required atmospheric carbon dioxide 3.67 amount to fix the one carbon dioxide. So therefore, if we assuming that if we come up with the one tree with the allometric model, so biomass is uh, the dry biomass is assuming that 50 kilograms to the out of that 50 total weight is carbon to that is the approximately 25%. Now, to estimate the ability amount of carbon dioxide absorbed, you have to multiply it with 3.67. So with that, we can estimate how much of carbon dioxide absorbed by that particular tree if it is if we can take that type of measurement. Or sometimes in this forestry kind of a project, what we do is we even we have to estimate the growth of the tree in a particular time period. For example, for that actually there are certain approaches to model growth. So we have to predict the growth and the diameter and height, and then based on that predictions, we have to estimate how much of carbon dioxide are sequestered in this tree. So in addition to that, these actually individual type of method. In addition to that, some estimates are available uh, in uh, relation with the extent. If it is uh, single type of tree in the plantation, so there are certain estimates available that we can calculate total amount of carbon dioxide, what we call the standing stock, or the amount of carbon dioxide sequestrated by that particular the forest land. So, however, the methods are available to estimate the emission of the trees. There's another question: is there any adverse impact on groundwater aquifers from direct air capture? Yes, that is actually something debatable one. In that particular case, the carbon capture and sequestration, or the what we call the geosequestration. So they do where the fossil fuel are extracted. In that example that what I have shown in the Iceland, they in that region they have a geothermal energy related electricity generation, and they captured atmospheric carbon dioxide and they pump into these deep areas, actually, which is not linked with the water bodies. But however, there are certain argument, there can be some kind of imbalance of uh, the stability of the lithosphere in certain areas. We add more and more uh, carbon dioxide into that. So these are some of the issues. However, technically they have to balance out if they see these type of issues. And also in the uh, ocean sequestration, uh, also there are certain arguments that if we add more and more carbon dioxide in the ocean, there can be issue of increase in the acidity. So those are some of the technical issues. However, even any kind of a project, they have to analyze these environment impact before implement, and they have to maintain the balance of that. So they have to maintain the threshold of uh, uh, if they use even the sea sequestration or the ocean sequestration or earth sequestration. So they have to look into that aspect. International carbon market. The question is how can Sri Lanka, how Sri Lanka can increase the involvement in international carbon market. Now, in Sri Lanka also there are, now, this is all about the credibility. that's why what I have mentioned previously in these registries, those are internationally recognized registries. And if we have a project in Sri Lanka to create uh, carbon credit, for example, we take tree planting. Actually, I can disclose that the Hiniduma Kandilia project, even you can go to the website Plan Vivo and you can find that project as well. So in that particular credit project is registered in international registry. Now we see that some of the demand for this type of project from uh, outside countries, or the countries in the different other countries, not from Sri Lankan context. So if we have projects, there's a possibility to trade some of the or the trade this credit and get some uh, income to run this project. So, however, the problem here in Sri Lanka is and there are few projects are registered under the different schemes like gold standard. There are mini hydro projects. Few mini hydro projects are registered in the global market under the scheme called gold standard. And those are also in international market. So the problem here is the scalability, and also we can come up with a project, but and having a project creating carbon credit is not enough. We have to find buyers to sell those. Otherwise, the investment for the project is sometimes kind of a problematic. And also, the countries like us, we don't have, for example, if we take a forestry kind of project, we need to have a large area to come up with more valued, or the more the volume of credit to be generated. Otherwise, the investment of project development is somewhat difficult to recover. So those type of things are some of the issues in uh, developing carbon credit to sell in the international market. However, there are things are happening other way around now, especially in some of the industries. Even I have shown some of the examples. They have claimed their products are carbon neutral, sometimes because of the requirement of the outside the global buyers for the to get the competitive market in the global context. So therefore, they prefer to come up with some of the claim like carbon neutral. Sometimes buyers are requested our producers to make their products carbon neutral. In that context, sometimes they might need to purchase carbon credit from international registries. Sometimes, unfortunately, they have to purchase carbon credit from countries outside by sending money for their project. So those are some of the uh, we can say those are issues, but these are some of the limitations in engaging in the international carbon market. However, so if you share that experience in the Kandalia project, it's very limited credits being generated, very less, about 3,000 or 5,000. Up to now, it's around, I think, 10,000, closer to 10,000 credits already generated. And there's a big demand, as that is kind of a very unique project in Sri Lankan context. So it's kind of engage with community, with multiple trees, creating more benefit for the biodiversity and things. So therefore, the buyers or the somebody's looking to purchase carbon credits, they are attracted to these type of things. Therefore, they can sell at a higher rate. That's why when you look at these carbon prices, the price of the carbon credit is depend on the demand. So more environment friendly projects are having more demand. People are if somebody is going looking for purchasing carbon credit. Yes, actually, there's a question, did the temporary reduction in greenhouse gas emission during the COVID-19 pandemic have a significant impact of global warming, or does the problem of global warming persist at the same level after the pandemic? Now, this is a good question. Actually, there was some uh, discussion on that, and it's not much significant. However, for the history of the world, these type of the history of the world mean the human uh, the very recent era with the human activities. For that 1.5 year period, actually almost all the human activities being stopped. Now you know that the burning of fossil fuel reduced to certain level, and that time if you look at some of the emissions, so the reduction of releases of emission is being actually reduced. However, the global warming now, that's why in 2023, the hottest year for if you look at the last the history of the earth. So temporarily it reduces to a certain level, but however the impact is still persist. Yes, we can. Yeah, we can help. If you are interested, there's a questions. Yes, there are certain projects, and if you are interested on getting more understanding of this carbon credit projects and things, we can support you to engage in some of the projects.
So I think the question's finished, right? Hello?
There are a few hand raises.
Hello.
Yes.
Sir, I am working in a project in Colombo called as Port Access Elevated Highway Project, funded by
Okay.
ADB. Yeah.
Right.
Now actually it is stage of the end of the project.
Okay.
Actually, we are using metric tons. We can, I mean, all that project is actually we are using the concretes actually.
Okay.
Columns and elevated highway.
Mhm.
I want to know, sir, actually, so many concretes we are using piers and concrete bridge segments.
Mhm.
In the future, any impacts for the environment? Air, air due to the concretes or something. But what is the relationship between the concrete surface and air? Some carbon dioxide sinking or any? I don't know actually. What's any relationship between that air and concretes? Heating or
Uh,
something? Yeah.
okay. To my understanding with the question now, concrete. Yes. Now to produce concrete, there are we can explain in a different ways. Now, if you look at the use of concrete, you have to
Yes.
use now if you look, we know the manufacturing of process of cement, so we need to
Yes.
have calcium carbonate and other material, and you need to burn.
Yeah.
Obviously, by burning that, producing clinker, there are carbon dioxide emission, the obvious
Yes.
carbon dioxide emission. Now, if we take 1 kilogram of cement and the mixing of something, and if you take 1 cubic meter of concrete or something, we know that to produce of that cement or concrete, so there are some indirect emission of carbon dioxide or the greenhouse gases. Now, when producing cement at the production process, there are some direct emission. But however, we can estimate that emission, that amount of greenhouse gas for what particular 1 ton or 1 cubic meter or 1 kilo of amount of cement or a concrete. So that is kind of an indirect emission. However, as you asked that by manufacturing or by producing the concrete, releasing of carbon dioxide by this concrete, actually there can be certain, due to certain reason. For example, if the acidity of the rain or whatever, that will decay the cement, and there can be a possibility to release some of the greenhouse or the carbon dioxide due to certain reasons. So that actually, even with the furniture, wooden furniture, with the decay, even though it's very difficult to trace, but with the time of the product, there can be a decay, and with that, there can be some of the releases of greenhouse gases. So that can be happen. On the other hand, I don't know exactly the porosity of the cement will trap and fix carbon dioxide in the form of the bond with the cement. So there can be possibility. And so in addition to that, and there are certain newer technologies already developed, improved approaches to trap and absorb atmospheric carbon in certain materials, not exactly with this type of cement, but there can be a possibility to develop improved different type of material where atmospheric carbon dioxide or any kind of a greenhouse gas trapped inside and creating a kind of a chemical bond that also help to reduce atmospheric carbon dioxide or other greenhouse gas. But
So
however,
you mean that is not a negative impact, that is a positive impact, sir?
that is the positive impact. However, manufacturing of cement, there's a climate negative impact is there, because when we burn calcium carbonate to produce clinker, there's a obvious emission of carbon dioxide. That is a negative impact. And with that, there can be, and actually there are certain improved the even some of the paint, some of the materials are now in under experimental stages to absorb atmospheric carbon dioxide or other greenhouse gases to fix. That is actually a positive approach. Now, when we look at all these, even with that the example that I have shown you, the atmospheric carbon dioxide capturing in the Iceland. So to manufacture that process or the product, there can be not can be actually obvious emission during the process of production of these material and things. However, these are what we call the leakages of carbon, the sequestration project. So this is
So I
what
saw one article, that man-made concrete. I think man-made, not Sri Lanka. I think I can't remember the country. That mean carbon dioxide gas can sink to that man-made concrete to something. I
yes.
think that is the. I think that is actually that is the research that done for the carbon sink. I think the one of the research. How we can carbon dioxide, how to trap to the rock or man-made
Yes.
concrete. Actually, and normally in highway, so many parapet walls there. Parapet wall mean actual protection wall in Sri Lanka, southern central highway. That our indoor project also 500 5 kilometer 5.27 kilometer. This length is from Grd.I to Golpace. That both from beginning to the end. That is a parapet wall that's also made by the concrete. Actually, that is not that also I think significantly mass concrete. I also I want to know, sir, that what is the difference between concrete and rock? That heat emission, that is actually concrete emission is less than or higher than?
Sorry, actually, this now ability to absorb thermal energy in different materials are vary, but exactly I cannot say now. For example, some of the exposed the rocks, if it is a dark color one,
Yeah.
we know
Anyway,
that.
sun yeah, that
Yeah.
solar power is normally sun is the solar that a source, no? That is a source, no? That after I mean that sometimes maybe concrete maybe at the night maybe cool or some it's that's the phenomenon there, no? That
Yes,
emission.
exactly. I cannot actually uh, uh, give a answer for that exactly. There can be different variations even when you look at the different locations, and those different parameters can be affected too. However, the different materials have different ability of absorbing solar radiation or the thermal energy, and the
Yes.
releasing back or the dissipating of the solar energy. This ability are different, but I don't know exactly what is the difference between this concrete and the rocks.
Okay, thank you, sir. Thank you.
Okay.
Thank you, sir, and thank you all for joining us today for this insightful Green Talk. A special thank you to our esteemed resource person, Dr. Sampath Wahala, for sharing your valuable expertise and shedding light on such an important topic. Your insights have truly enriched our understanding and inspired us to take a meaningful action. And to our audience, your active participation and thoughtful engagement made this session even more impactful. Let us take the knowledge we have gained today and apply it to drive positive change in our communities and beyond. Together, we can continue to champion sustainability and work towards as a greener, more resilient future. Thank you once again, and we look forward to seeing you at our next Green Talk. Thank you so much, sir.
Thank you.
Thank you.